And without further ado, I'll introduce our first speaker here, Natalia.
Hello, and thank you for coming to the breakout session so early. I know for many of you it was a long trip to here. My name is Natalia Semenova. I work for Google Cloud Canada. I'm based in Toronto, and I would like to talk a little bit about the incident response in multi-cloud, particularly for IoT, and what can you do to be better prepared for responding to incidents. Just a little bit about myself, just not to brag. Before Google, I've been working for several well-known companies, and overall, I'm about 18 years in information security. So the opinions that I am expressing are based on my personal experience. It's not the official position of Google or Google Cloud. And in particular, I like to work from some unusual places. Here I am with my laptop at Kilimanjaro, and internet connection there is quite good, I would say. So your IoT is not secure even there if you don't secure it properly. So I will talk today a little bit about the use cases for IoT in the cloud, just to make sure we're on the same page. We'll discuss some most common threats for IoT and the issues that you would most likely encounter when dealing with IoT in multi-cloud. And there will be some real-life examples and a case study for the incident response process that is like more or less adhering to best practices. So what are the different use cases for IoT in the cloud? First of all, we divide those IoTs in two categories. There are consumer IoT, so anything that people usually put at their house or in their car, or they carry on themselves, like medical implants, for example. And then there are non-consumer IoTs, anything from cargo ships and the devices that used to be SCADA, and something that you will see more and more often, the gas pumps. So my case study would be about the gas pumps. Some common threats for IoT in the cloud specifically are possibility that the device would be infected with malware, and then this malware can turn the device into the DDoS bot, or exfiltrate data from the device, manipulate the data, or even mine a cryptocurrency. Then for consumer devices, one of the threats is a device takeover. Let's say you have a webcam, and then the adversary would be able to use this webcam to see what's going on in the house. And the most cloud-specific threat is the resource over-provisioning. So that means once a device is taken over, or if the adversary is able to register themselves as a device, they may be able to start requesting more and more resources. If you don't have a limit, then you will end up like this meme, you know, two people looking not very good, asking why, because I forgot to shut down my cloud compute instance. Yeah, so most of the examples that are available for public that speak about the cloud IoT compromise related to consumer devices. That could be partially because the consumer devices are more widely spread, or maybe because the companies don't like to talk about the compromise of their cargo ships. One example is the Amazon web cameras. They were not set up according to best security practices, which resulted in the fact that not only the employees can have full access to videos of the customers, but also adversaries were able to establish two-way communications and actually talk to people at homes using those web cameras, which resulted in a massive lawsuit. And the company lost money. But as far as I know, the web cameras are still on the market. Just now they are set up better, hopefully. So if you think about the non-consumer devices, the most cases are related to worms infecting the SCADA devices, but at that point it was not that bad because unlike IoTs, SCADA devices usually only communicate with the devices of their own type. That means, for example, now for IoT you have a web camera. It can easily communicate with the router. It can easily communicate with your smart home because they are using HTTP or HTTPS protocols. For SCADA, they are using their own protocols, so that limits blast radius a little bit. So what is special about multi-cloud incident response? So we will talk mostly about two stages of incident response. That is how you can prepare to the incident response and how can you detect the response. Because that are those two stages are the most critical for the multi-clouds, and they are different from a single cloud or on-premise. The problems with multi-cloud, the first one is like, where are my logs? Because you have logs in every cloud. You have logs on-premise, and maybe you were trying to aggregate all the logs, but have you ever tested that all the logs are synced properly and are correlated properly? Then because what is normal for one cloud may be not normal for another cloud, it is hard to say if that's an incident or not. Let's say one example, you are using one cloud just for machine learning and another cloud you use for developing software. So the usage patterns of those two clouds are different, and the baselines are also different. You may allow your developers to perform some manual configuration, while in machine learning you would like to deploy everything with Terraform, so no manual changes. Therefore, in one cloud, any manual change would be an incident. In another, it would be not. Another is who is responsible, because most typically the cloud adoption comes in phases. So for one cloud, which is for developers, there are some cases where developers can maintain it themselves because they wanted it for themselves. For the other cloud, because it's, for example, Office 365, it's for business users, and business users do not want to maintain the cloud, so it's maintained by administrators. And when administrators also want to get their hands on the developer's cloud, they are faced with resistance. And sometimes they just leave the situation as it is. And also one thing is, if you suspect that something is wrong with the cloud and you want to contact somebody on the cloud service provider side, who would that be? On the other hand, if somebody from a cloud service provider wants to contact you, they may not necessarily know whom to contact. I have one example when it took 5 days for the cloud service provider to figure out whom to contact at the company when there was already crypto mining going on. So they just ended up by shutting down all the instances they suspected and proceeded to finding out the contact person in the company. So that's not a good example. So you can see that in multi-cloud, this architecture can be a bit tricky. Sometimes you have one cloud just as a source of your identities, and the other clouds may or may not rely on those identities, or they may have some separate identities. And one or more of those clouds is communicating with IoT. So if you don't document all those flows, if you don't perform a threat modeling, you would basically end up with this picture. Do you really understand your multi-cloud architecture? Do you understand if all the clouds really synchronize with CIM? And which cloud is getting the data from IoT? And is it possible for IoT to communicate with more than one cloud? So this picture is an example of a very bad architecture documentation, which will be a problem when you decide to do the incident response. So make sure your architecture don't look like this picture. In course of my experience with working with incidents, the most common root causes of issues that we faced with identifying and detecting incidents were that there were some logs missing from CIM. Sometimes it was due to cost cutting, because it is normally free to put data in the cloud, but when you try to pull data out of the cloud, including logs, that incurs some charges. And sometimes people think, okay, maybe I don't need all those terabytes, gigabytes of logs, and maybe at some point I will do something with normalizing those logs, so I can only put the half of my CM, but then it goes postponed and postponed, and when the incident comes, it's not ready. Then the blueprints may be different for the clouds, or for some clouds they may not exist. If some cloud was adopted relatively early, when security was not such a big thing in the perception of the cloud customer, or when it was not clear in the share responsibility model, sometimes it was such a perception that, okay, now data in the cloud, we don't have much responsibility for it, so why do we need the blueprint at all? Then there could be different contract conditions with each cloud. Because when we speak about cloud, sometimes we have just an infrastructure, or sometimes we have a software as a service to manage something. Depending on this, the share of the responsibility for the security is different, and that must be understood. So if you have infrastructure in the cloud, that means you are responsible for the updates of all your devices that are there. If you have software in the cloud, software as a service, then the updates are usually installed automatically. So important not to miss this point. And also one cause and a major source of pain is the problems with mapping the identities between the clouds. So if you have one account for a user in the cloud, maybe you're using single sign-on, maybe you just let user have their separate accounts in each cloud, and then in one it would be Jane Smith, in another it would be J Smith, in the third cloud it would be user 001. Hard to understand, and especially for the service accounts, because we speak about IoTs, which are usually represented by service accounts. Some clouds allow tagging or adding the service account owner attribute. Others do not allow. Then it's just hard to understand about which identity we're talking about. In the next slide, I will talk a little bit about how to try and adhere to the best practices that would put you in a better posture when it comes time to respond to the incident. Make sure that in your clouds, all the IoT devices and their respective service account are searchable. Especially make sure that there is an owner identified for each group of devices. So if the incident is detected in a certain group, you know whom to contact. So it's more like divide and conquer, I would say. So if you group your devices and you can say those devices must be at minimum at this firmware version. Or those devices are serving to this application. So if there is something wrong with those devices, that means that incident is to this application. If you are updating your devices, if you are responsible for updating your devices, make sure that this update process is regular and monitored. So make sure you don't have this device as if you don't have a device as a service, you need to update it. Make sure that your blueprint includes requirements for logging and monitoring to understand what information you are requested and what information you are passing to CM. And also make sure that your blueprint includes a process of quarantining the devices. Because sometimes nobody knows, okay, there is something going on with those devices, but can we really isolate them? Can we really do something to reduce the blast radius or impact on the rest of our infrastructure? So the good example here is Deutsche Telekom, which was infected by the Meyer worm, and because they were not able to isolate it fast enough, it resulted in outage of 800,000 routers at end customers. And they had to ask the customers to return their routers because they were not able to update them or do anything remotely anymore. So that's a big impact. So some challenges that you may face when creating this common blueprint. Again, I already spoke about them. Some example here is when one security is trying to speak to IT, saying, hey, now we have this blueprint that all service accounts must have owners. We identified those owners. Here is a spreadsheet, device, and the owner. Could you please launch the script in your cloud and put the owner's information there in the cloud? The IT says, hey, but this owner and the blueprint, it's your information security responsibility. We will not run this script. We can give you admin access, so you run the script. But the IT security says no, if we run the script once, the access remains, and the cloud guys would assume that we will always do some things. So it's now political. And days and weeks come, and still there is no information about owners in the cloud. So who wins? Probably the adversaries. Then also one issue to create the blueprint can be that different clouds use very similar names for the resources, but actually this is corresponding to different concepts. For example, organization in AWS, it's not the same as organization in GCP. So that could be misleading. If we say every organization in the cloud must have those and those settings. Sometimes it just doesn't make sense for the other vendor. So it really requires a good, good degree of understanding. As you may have noticed, out of the things that I discussed in previous slides, lots of problems come from the people side, from the office politics here, because sometimes everyone wants to be responsible for some cloud because it's a high impact project. Sometimes nobody wants to be responsible, or sometimes people try to get more resources by claiming their responsibility, and then the budget is cut, which results that responsibility was claimed, but there is no people resource to back up that decision. Good approach would be to create the dedicated cloud security and architecture team, which would be responsible for the entire multi-cloud, and make sure that the resources are then adequate. So the resources are not being dragged among different teams with different managers. And of course, always collect cloud users' feedback. One example could be that the security team doesn't have an understanding that you cannot protect the cloud just by imposing firewall rules. So it's like old school. They say, okay, we just like block everything except for port 80 and 443, and we should be as secure as on-premise. So that doesn't work. So if you collect the user's feedback, they would be unhappy because lots of services do not work anymore. So next few slides, I will come to some technically specific issues. For example, one issue with log collection, which I mentioned. So the good approach would be to do some cost optimization to understand which direction of the logs or the logs flow would be more cost beneficial, because some people also have their CIM in the cloud itself. So maybe the cloud that produces the most amount of logs should be also the same cloud that hosts your CIM. Because you don't want to pump too much logs out of the cloud. And think about using cloud vendor-specific tools to optimize and minimize the amount of logs before you put them out of the cloud. Otherwise, it really may be costly. And think of the ways how you would correlate those events among different clouds. One approach would be to use certain naming conventions for users and service accounts and the resources. So that then it's much easier to correlate if in one you're just using some random alphanumeric names, and in another you are using some conventions like resource, department, team, project. So make sure everything is documented, so it's not some ad hoc meeting notes somewhere. And make sure there is a process before any system goes to production, that there is a verification that it was set up particularly that way. So there should be a sign-off process to check it. Then also good practice would be to monitor any cloud environments that are supposed to generate logs, but for some reason do not generate them. Usually that's not normal. That means that the integration is broken somewhere. And it's better that you find it out before there would be some incident you don't know about. One big pain point is IAM. So as I already mentioned, it's not enough to isolate your cloud by firewalls, because the new perimeter of protection is identity. So you need to ensure that you are using either single sign-on to eliminate the number of identity repositories, or you are using proper mapping. Then you need to introduce the practices of managing employee accounts or human accounts, then the highly privileged accounts, and then the service accounts. So you cannot just manage identities in general, because they have different requirements. Also, if you are using impersonation for some reason, for example, one cloud wants to have access to another cloud, make sure you understand how it works and you are able to trace back what account from that cloud impersonated another. So you don't have any kind of rogue, unregulated accounts in one cloud, in one compromised cloud, that would impersonate legitimate account in the other cloud, and then in the other cloud the operation would look legitimate. Also avoid using long-lived credentials. So in case of an account compromise in one cloud, you would at least ensure that after 24 hours or 12 hours, unless the adversary has taken control of the ticket issuing authority, the true service account would lose access. Also use centralized management, which is a preferable way for auditing, because you can perform periodical audits and see if you have too many identities, if you have identities of employees, partners who already left the company, or if you have some decommissioned IoT devices that should no longer have representation in directory. And the last part of advice would be about the costs. So as you know, in risk management, you can either accept risk, mitigate risk, or transfer risk. So for such threats as DDoS attack, the mitigation part would be, of course, to limit the amount of resources that a certain IoT or group of IoTs can consume. But as a transfer part, you may see if your service provider is offering some kind of program. So if it's a registered DDoS attack, that some costs can be mitigated in the form of insurance. Then the normalization and cleanup of logs, which I already told you. So if the cloud service provider offers you some kind of security dashboard with the alerts that come up automatically, you may think, okay, I will only forward those alerts to CIM, because it would be like maybe 1 or 2% of all the logs that are actually generated. So the significantly reduction in price. The real life example of the successful incident response, very briefly. So I was involved in incident response for one Middle Eastern company which had issues with their gas pumps. Some of them were infected with malware, which allowed certain cars to fuel up without paying practically anything. And it was very hard to detect because the logging from those pumps were just billing related. It was okay, the car has pumped, and now we got one cent paid, and the car is gone, but everything legitimate. So we had to set up the whole logging procedure to understand how much of fuel goes away for free. And that involved communication between 2 cloud teams. So one cloud team that was responsible for the cloud that actually operated the pumps, so like their CI/CD pipeline, and the second team that ingested the data to do some machine learning to predict the prices and the dispatching of trucks to replenish the fuel pumps. So that was a very, very lengthy process, and the core was that nobody even scanned the gas pumps for malware whatsoever, because it was believed that it's not a real computer. How come? So yes, it's important to understand. For that, I'm concluding my presentation. If you have any questions, we still have like 12 or 13 minutes.
Can vendors of IoT devices, multiple that they are, should they be doing more? Should they be perhaps more respectful of security needs in their core design?
Right now, as far as I'm aware, there are initiatives from OWASP and NIST to introduce common security standards for IoT devices, divided by consumer and non-consumer, but it's in a very early stage. And I believe that unless there would be those hard requirements, such as PCI DSS or HIPAA, but towards IoT devices, there won't be a common platform. For medical devices, I think now they are hardening up. So at some point, you won't be able to sell or produce a device that is not corresponding to the standards. But not for gas pumps. Did I answer your question? Huh?
So what was the vector for infection at the gas pumps?
The vector was a lack of authentication. The adversaries were able to upload their data to the bucket in the cloud that was used by the pumps to get the updates. So it was set up in a form of what you would call before the FTP server, but updates were just in the bucket, not signed whatsoever, and that's how the malware got on the pumps. Yeah.
So in finding the open bucket, were you able to uncover any methodology or anything they used to find these open buckets or find the fact that that bucket attached to that particular client?
So the bucket by itself, it was not open. However, it was used by multiple departments because in many clouds, once you have access to some files in the bucket, you basically have access to all the folders in this, all the objects in this bucket.